Last time we learned about the search algorithms, um, as in depth first algorithm, search algorithm that uses the frontier type stack that allow us to, well, in practical terms, search as deep as possible in nodes. So, in practical terms, a deep first approach would go as deep as possible. For example, if it's trying to go through a maze, it will go into a dead end, it will go into one specific path until it hits a dead end. Then it will try to find the other way. And also about the breadth first, it uses the queue data type, which is, well, first in, first out data type. And it's very interesting the comparison, and I did a little bit of comparison yesterday by showing how they would behave into a simple node approach to go A to D, and it was very simple, really, extremely simple. So today I decided to do something different. I want to compare them into a more, not realistic, but a better way to show how they work. So, well, in a puzzle. So let's begin. First, again, we have the stack data type, which is what we're going to use today. Today we're going to specifically look at deep first, sorry, approach, which is uses stack type frontier. So last in, first out data type. And well, if you would compare it to against, we would compare the deep first search again that always expand deepest node in the frontier by comparing it to the queue type data type, which is the first in first out, which again is part of the breadth first search algorithm. Now I'm going to show how they work in this little example, which is a simple maze like this. You need to get from point A to point B. Easy enough. So, well, again, we are going now to test the deep first search approach. So, well, buckle up because we have a lot to see. Okay, this is the maze we're going to use. And the first thing our artificial intelligence will do, it will search the frontier. What is my frontier? Again, considering my frontier is just what's in front of me. So from A would be this. So it's going to keep going like a snake, and there is not much to say really about here. You will see the next frontier is here, the next frontier is here, here, and here, until it hits here. Now it has a choice, and this is where our well, this is where our deep first approach comes in hand, because now in this decision is that how it differs from, well, breadth first. So let's see how it would work. In this case, this not necessarily go to the right or left. So I have nothing saying that I need to go into one side. So it can pick either. Let's say for the sake of example, it goes to, well, to the left. And now I put here this yellow one, just saying that, well, here is my, it's still on the frontier. This part at least is still on the frontier, and this is still an option. So we still go here until it finds the same problem. It has two paths. Now in these two paths, it will choose, let's say, well, you can choose any really. You can choose, for example, let's say choose the right one. That goes to the maximum, hits a dead end, so there's nothing more here. And so the last one that came in, which is this decision, is now, or in this case, this would be the frontier, is now where, well, where it would decide to go. So in this case, it will fill up everything here, and then it will continue from where we left. So here we go again. We continue growing. Nothing here is it's stopping it. So it goes until here, and again, it's very arbitrary since we didn't put anything saying that it has a preference to go, for example, going to the right side or up or down or left. So it's really random here. So we could choose to go up, and then since it's a dead end, it will try to go right again. So it now finds itself into, again, more of a uh, option. Let's say, well, it chooses to go right this time. Finds itself in another little uh, separation here. So it has to choose between going up or down. Let's say it goes up, just to show really. Again, it's pretty random. It has a 50-50% chance to choose either. So again, since the last ink, again, since the last ink was this one, you will now still grow from here. So it will eventually go to B. Boom, we have it finished. Now, again, because it is, well, arbitrary, it has percentage of a chance, so it's not exactly programmed in. It could, for example, choose to go here. It could 100% go into this path, or it could just go right away, not getting caught here, neither here. Now, what would be the benefits? Well, it always finds the path in a finite number of possibilities, which, believe it or not, but artificial intelligence sometimes works with infinite possibilities. So sometimes this is not the best analogy you would try, but uh, if it's finite, for example, if I have a finite number of squares in this puzzle, which you can see I have, and not infinite, it will eventually, well, eventually find a way. But this solution it finds, is it, well, the optional solution? It is the lowest possible. Uh, it is the lowest possible number of moves to get to point A to B. It depends, really. Uh, yeah, it's kind of a weird answer, but if perhaps really, again, because it's chance, it's really by chance you would go find an optimal solution. So again, let's, for example, try this maze here. This actually exemplifies a bit better. It could originally try to go to the right, choosing the optimal path, the best path possible. But the same chance there is to go to going to the right, to my artificial intelligence decides to go to the right, it could take the least optimal approach and going to the left. It could even take a technically even less effective direction, and could, for example, well, go here, might go here or go here. But well, it is interesting indeed. Again, if it might find the best possible solution in any situation, but not always. And well, again, if you see how it works, because it pretty much works like a snake, or I could say a person movie. If you are exploring a cave, finding for a treasure, for example. So my treasure in this case being, well, point B. So again, let's go back here. My treasure here going point B. My treasurer, or sorry, my explorer, which again is my artificial intelligence, could, well, go right to the caves, then go up, then right, then up again to find the treasure room. It could, as very well, just go up and up and up and right and then down. It could go right till here. It could go here, and eventually it will stumble on. If the cave is not infinite, well, meaning a lot of time, it will eventually find a treasure room, which is B. But well, that's supposing we not have an infinite quantity of, well, of possibilities. In this case, we don't need to worry much about that. especially if you kind of try to put infinity into perspective. Well, it's an infinite number of ways to think about it. But that's pretty much how deep first search would fare. Not fare against something because we haven't looked at a competitor, but well, next time we'll see how breadth first compares, or well, meaning how breadth first will do the same puzzle, and well, really how different it looks visually. Not just visually, but how different it looks in general. It works. So again, if you are very interested in that, look at the next video. So for that, subscribe and hit the notification bell so you will receive a notification when my video comes around. And not just that, but leave a like if you like this video in particular. Leave in the comments any idea, for example, you have about this from artificial intelligence, or you know, apps, any idea you have about how it works. And also, if you want to understand it better, you could access the course. Again, I'm not sure if you could actually enter. Actually, leave the comments down below because it's a course from it's a course from Harvard, so very cool indeed. But I think he might have a limited number of, well, of maybe not from access, but a limited number of, not a limited number, but a limited date. So when you can enter, but try it out anyway. I put in the description, and well, I think that's it for today. If you like it, again, subscribe, like, and leave it as comment down below. That's it. Tomorrow, seeing you for breath first search. Bye.